this example, we are given a series RLC circuit. We have an inductor, resistor, and capacitor connected in series to an AC generator. The resistance value is 2 ohms. The capacitance value is 15 millifarad. And the inductance value is 30 millihenry. And we are told it is given a current, it has a current of 0.5 sine of 8 pi t amps. And we are asked to calculate the maximum voltage across R, C, and L. Remember Ohm's law for the maximum voltage across the resistance. V is equal to Ri. So V max is going to be I max R. In the expression for I, remember what that expression means. It is I max, or the amplitude of the current, sine of 2 pi ft. That's the expression. So we just compare both expressions. That leads us to find out that I max is actually 0.5 amps. And in this case, then VR max is just 0.5 amps times 2 ohms, the resistance. So that gives us 1 volt. Now, for VC max, we have a similar expression, but it is I max times the capacitive reactance. If you recall, the capacitive reactance is 1 over 2 pi fc. Now again, comparing this expression to the given expression, we see that 2 pi f is actually 8 pi in this case. So my xc is actually 1 over 8 pi times c, which is 15 10 to the minus 3 farads. Okay, once you calculate that, you should be able to find something around 1.3 volts. The last one is the voltage, the maximum voltage or the peak voltage across the inductor. So again, we need to find the inductive reactance, and in this case it is 2 pi FL. Remember, we could write it as well, XL is omega L. Remember, 2 pi F is the same as omega. And in this case, it is 8 pi times L, which is 30 10 to the minus 3 henries. So once we solve that, we should be able, once we multiply that by 0.5 amps, we should be able to find 0.38 volts. Or keeping the same number of significant digits, 0.4 volts. Okay, now remember, we could have been asked to find the RMS values instead. The RMS values would be the same as these, but divided by square root of 2. The second question here, he's asking us, now that the frequency is increased, notice instead of 8 pi we have 16 pi, so that means we doubled the frequency. Which element's maximum voltage decreases? Okay, and that's what you need to remember. VR max is I max times R. It does not depend on the frequency. VC max depends on the frequency, and the frequency is in the denominator, in XC. So if F increases, since F is in the denominator, VC max decreases. VR max stays constant. VL max, since F is proportional to XL. So so VL then becomes proportional to F. So VL max is going to increase. So the one that's going to decrease, according to the question, is VC max.